Okay, our final speaker before we take a break is Karen Emmorey. Her co-authors are Gabriella Mead, Catherine Midgley, and Philip Holcomb from San Diego State University, ERP Evidence for Implicit Activation of ASL in Deaf Bimodal Bilinguals.
You can hit play for me. Excellent. That's all right, I can just look at the... Thanks for hanging in there. Of course, again, and now for something completely different. So I want to recognize Gabriella Mead as the lead author on this work, and also Kathy Midgley and Phil Holcomb are here. So any very difficult ERP questions will be directed directly to them. All right. So one of the things we know from what I'm going to call unimodal bilinguals, that is people who know two spoken languages, is there's lots of evidence that both of those languages are activated at the same time, even when there's only one target language or other language is always on. Okay? And this also leads then to a demand to actually have to suppress that language when it's not the target language. So there's these activation and inhibition processes going on. So I'm interested in bimodal bilinguals. So these are people either deaf or hearing who know a spoken and a signed language. Okay? What are the activation and inhibition processes for these types of bilinguals? So some previous work that we've done suggests some interesting avenues of co-activation that may be kind of unique for this population. So when hearing bilinguals are talking to English monolingual speakers, it turns out that they unintentionally and probably unconsciously will produce ASL grammatical facial expressions. So when asking a conditional question, they'll raise their eyebrows, or when they're asking a WH question, they'll furrow those brows. Those are grammatical markers in ASL, but they're coming out when the person is speaking English to someone who doesn't know ASL. They'll also produce ASL signs when talking to someone who doesn't know ASL. Okay? Corpus work looking at unimodal bilinguals suggests that this kind of sort of error is really rare, where you're talking to a monolingual and an unintentional Spanish word comes out. It happens occasionally, but it's really rare. This phenomena happens all the time when bimodals are talking to monolinguals. Okay, so this led us to think about looking at these processes. And the experiment I'm going to tell you about is based on a now fairly famous study by Thierry and Wu, which was an ERP study with Chinese English bilinguals. And they were presented English words. It was completely all in English. And they were asked to make a semantic relatedness decision. Are these two words related or not? But what they secretly did was they manipulated the translations of those English words so that some of them had a character that was shared in Chinese, so that they were related in form in Chinese. And you could compare these, both the yes decisions and the no decisions, where there was a relationship in Chinese, to an unrelated condition where the translations were not related in Chinese. Okay? Now, interestingly, the participants in this study had no clue about this manipulation. When they were asked afterwards, did you notice anything about the stimuli? They didn't say that they noticed that, oh, some of them were related in Chinese, okay? Even though they didn't know, their brain knew. So when they looked at the brain waves to these pairs that were related in Chinese versus not related, they saw this classic, what's called an N400 response, where you find more negative. Do I have my thing here? You can see that. More negative for the unrelated in Chinese compared to the related in Chinese. So this is an indication of facilitation of processing of those words, those target words that were preceded by a prime that was related in Chinese, okay, the Chinese form relation. Okay, so this happens about 400 milliseconds after the onset of the word. But when we look at their response times, their decision times, it didn't matter whether there was a relationship in Chinese or not. Okay, so just if you look at these guys here, it didn't matter. Okay, so it didn't influence their behavior. Okay. So what's the explanation for this type of pattern that we see? Well, so for the N400, it's a priming effect. And the idea is that it happens through spreading activation within your two lexicons, okay? So the English word activates its Chinese translation kind of automatically. Activation spreads through the Chinese lexicon. You also get activation from Chinese to English. And so this spreading activation makes this English target word easier to process in some way, okay? But then what happens a few hundred milliseconds later is that now you have the behavioral response, you're deciding whether these are related or not, and there's no effect. And so the explanation is what happens is that activation of Chinese is rapidly suppressed, so it doesn't affect behavior. Okay. So what about bimodal bilinguals? Okay, well, this type of work has been done behaviorally with both deaf and hearing people who know English and ASL. And they're the same task, make a semantic decision to pairs of English words, so in this case, movie and paper. Okay? But it turns out that movie and paper in ASL are form related. Okay? So here, I'll show you what these look like really quick. So movie and paper. And what they found was exactly what, well, they find a behavioral effect. So we're going to focus primarily on the semantic unrelated condition here. All right. And what you see is longer response times to movie and paper to these words that are formationally related in English when you have to make a no decision. It goes in the opposite direction when you make a yes decision. The idea there is I have to say no, it's semantically related, but they're related in ASL by form. Okay. Now, what's important about this study is that there was no debrief at the end. So we don't know whether the participants were kind of strategically or consciously translating these English words into ASL, and that was what was influencing their behavior. Okay. So it's different from what we see with unimodal bilinguals. So we wanted to look at this both behaviorally and with ERPs. And our question was, if these behavioral effects are strategic, and it's a sort of a conscious effect, then we should see this difference in response time only for those people who report afterwards that they recognize that they were related in form in ASL, that they recognize the manipulation. And we shouldn't see this automatic spreading activation in the N400. What we should see is a late effect that's indicative of a strategic type of process. Okay? On the other hand, if these effects that have been seen in these other studies are really just a different manifestation of the same cognitive process, the same lexical process of spreading co-activation, then we should see behavioral effects for the bimodal bilinguals. This is different than what's seen in the unimodal bilinguals, but it's something that's happening automatically for all bilinguals. And we should see an N400 effect that's indicative of those lexical access spreading co-activation that's been seen in the unimodal bilinguals. Is everybody with me? Okay. All right, so here's what we did. We had 24 deaf, native, or very early exposed users of ASL. And I'll tell you right now, at debrief, 14 of those were unaware of the manipulation. I'm going to be talking about them as our implicit group. So they didn't notice anything about the English words that they were asked to make these decisions about. But 10 of them did. When asked about, did you notice anything, they reported recognizing that some of them were related. Now, this in itself is interesting because that never happens in the unimodal case. Nobody ever responds that they noticed a manipulation. At least that's what's been reported. So this is already kind of evidence that ASL, the other language, maintains activation in contrast to what's found for the unimodal bilinguals. So we also had a group of hearing people who didn't know ASL at all, so they shouldn't show any effects because they don't know ASL. Okay, and then we had all these wonderful word pairs that were matched for translation, consistency, and Gabriella is incredibly anal about stimuli, and so they're matched for everything. So frequency, blah, 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 everything. So we're going to look again, like I said, at the semantically unrelated case where you're making a no decision. Again, they're making these decisions to English words, but you have a hidden manipulation where some pairs are phonologically related in ASL, and I'll show you what nurse and sushi look like. Compared with idea, the unrelated one. Okay, so what did we find? Let's look at the behavior results. So happily, we replicated all of this other behavioral work where we see longer response times for those no decisions when there's a formulation in ASL. The hearing people who didn't know ASL showed no effect. That's good. When we look at the group that was not aware, we see a stronger effect than the group that was explicitly aware. Okay, so this is consistent with that hypothesis that, okay, what we're seeing in the bimodal bilinguals is the same type of lexicosemantic automatic coactivation of languages that we see in the unimodal case. Okay, but what about the brain? What do we see? So again, with our hearing people, we're looking at the difference between the ones that are ASL related and the ones that are not. Those two lines are on top of each other. You don't see any pretty colors in the brain maps. They are not, there's no difference between those pairs. So now when we look at the bimodal bilinguals here, I'm plotting negative up, so it's flipped from what you saw in the Thierry and Wu study, just to confuse you a little more. So what we see is a nice N400 effect. And this is when we look at everybody. We see an N400 effect, but we also see this late effect, okay? When we just look at the implicit group, we see primarily this N400 effect, suggesting that that late effect may be the strategic effect that you see in the guys who are explicitly aware. Okay, so what this suggests is that the timing of this cross-language activation in the N400 window, the polarity, the fact that you see more negative for the unrelated than the related, this is all consistent with what we see for the unimodal bilinguals. But what's different, as you'll notice, is this distribution. It's this right, I'm really bad at this. It has a right anterior distribution, and that's different than what you expect for a typical N400, where you should see blue in the center of the brain. So one question is simply, well, these are deaf readers. Is the N400 response different in this group for some reason? Well, happily, the answer is no. If you look at just the semantic priming effect, where you should get an N400 effect, so looking at the semantically related versus unrelated, the bimodal bilinguals look exactly like the hearing monolinguals with respect to the timing, with respect to the distribution of your classic N400 for semantically related versus unrelated words. So it's not that. So that suggests that the distribution that we're seeing is related to some aspect of form priming in ASL. So we've just completed a test to kind of look at that by presenting signs overtly. So this is, you're doing the exact same task, making the semantic decision, but not to English words where you have a hidden translation manipulation, but the actual signs. So you're making the decisions to pairs of nurse and sushi versus nurse and idea, or idea and nurse, okay? And what we get is a much stronger effect. This is explicitly presented form rather than implicit activation. But we also get this more anterior right lateralized response, suggesting that this is something about how form is processed in sign language compared to spoken language. Okay, so let me conclude. So the fact that what we found is when deaf readers read English words, they implicitly activate ASL, and that this process of spreading activation between your two languages, co-activating your two languages, happens regardless of the modality of your languages. It happens for spoken language as well as spoken and sign language. Where we see some differences is the after effects. So what we see for the unimodal bilinguals is less suppression, less inhibition of the non-target language of ASL compared to spoken language speakers. So for a unimodal bilingual, they are really sitting on that other language after it's activated. It can bubble along a bit for our bimodal bilinguals. There's less need for that control. And finally, our ERP results also point to some interesting differences between processing form in a spoken language than a sign language. So this fact that we see this anterior, right anterior distribution suggests that there might be a different neural generator for processing form in a sign language than in a spoken language. And thanks to all of our participants. Again, we really need to appreciate the people who volunteer to be in our studies. Without their support of our research, it's simply not possible to do this kind of work. So I think it's really important to thank our participants. That's it.
So we have time for questions.
Thank you. It's very interesting. In your conclusion slide, you talked about how you saw a difference in your implicit group, which was different from what Thierry and Wu found in the behavioral results. And in your explicit group, you saw something that was more similar to the Thierry and Wu results, right, with no difference in the response times?
Right. So one thing to keep in mind, the explicit group goes in the same direction,
right,
but they have really long response times. So because they're explicitly translating and have this other strategy, it's kind of slowing them down all over.
So my question is whether you think that the same explanation that Thierry and Wu used applies to this group, or whether you think because they're different in that they have this explicit knowledge, whether you think they might possibly be using more of a proactive regulation strategy, recognizing they don't need it, and therefore essentially trying not to let them let that information distract them from the task, which in English.
So what I think is going on, in fact, I didn't put the plot up of the explicit guys because with time I was not going to talk about them. You still see an N400 response, but it's weaker. We only had 10 subjects in that condition, so it didn't come out significant, but it's there. So the suggestion would be that this is what I would argue, is that you're getting that automatic spreading of co-activation in that group too, but then on top of that, because they are using this kind of strategy, you see that late effect that's indicative of sort of the strategic thing. So I think there's sort of two processes going on. One is kind of automatic and one is not. Does that answer your question?
Thank you.
I could just yell.
Oh, yeah?
Alternative hypothesis to the one.
Yeah, I see it. So I'm not quite sure I understand the argument. So the way the language was learned. So that would mean, I have to think about this a bit. So I guess I'm kind of arguing for the same explanation that you see in the Chinese English bilinguals and in the ASL English bilinguals. And you're saying that it looks the same, because you get an N400 for both, but that it's different for the signers because of the way signs are. So that's, no, it's interesting. And I'm trying to tie it because we actually are doing some work that's not quite tied to this, but one of the hypotheses we have is that the way that signs are linked to words may be different than the way words are connected between two spoken languages, in part because you don't have a written form of ASL. So you don't have an orthographic competition between the two languages. We think that might have an effect. We think there may also be really kind of interesting differences between deaf and hearing bilinguals because of how these words are learned and how they're connected. So I think there's a lot in that question about how the words were learned and how these associations are made that could create differences in the neural responses as well as to behavioral responses.
I have a question. I have one. So, do I need a microphone for you guys? Yeah? Okay. So this is maybe not what David was saying, but about the frontal or anterior at 400 you find, or negativity. It seems a lot like the type of effect that Kara Federmeyer finds in her prediction work with orthography. And I don't remember if it's phonological or orthographic now, but have you looked at the prediction work maybe to see if there's something strategic that even just monolinguals do that could be related to what these bimodal bilinguals are doing that even the Chinese English bilinguals wouldn't necessarily? I know that's a complicated.
So I'm not. This may be one of these difficult ones. I get these two guys come in, but
Yeah, sorry.
but I'm not sure about the prediction part. But one of the things we are thinking about is with respect to picture and other kinds of visual form overlap that we think might be involved.
Yeah.
And so it's not so much that it's prediction, but it's a different type. It's a visual form overlap.
Yeah.
Rather than.
It just seems like probably pretty related, since that's one of the main instances of those kind of frontal negativities that at least I'm most familiar with. But yeah.
So I'll let Phil or Kathy, do you guys want to add anything?
Sure.
You're good?
Thank you very much.
Okay.